Hello everyone, I am Nikhil Kumar and welcome back to the GitHub Action series. If you have been following along, we have already explored the basics of GitHub Action and how to automate pilot scans in workflow. If you missed those, don't worry. I have added the link in the description so you can catch up. Today we are diving into something super practical, setting up self-hosted runner for GitHub Actions. This will give you more flexibility, control and efficiency in your CI/CD workflow. So let's get started. First, let's understand what a self-hosted runner is and why it's worth setting up one. By default, GitHub provides GitHub hosted runners. These are cloud-based systems where your workflow are executed. They are great for getting started but come with limitations like restricted customization and resource constraints. On the other end, self-hosted runners are like having your own personal server for running workflows. It could be a VM, a physical server, or even your laptop. This option gives you custom configuration and total control over resources. Let's see why this might be a perfect choice for your projects. So why should you care about self-hosted runner? Here are three game-changing reasons. First is customization. You can tailor the environment by pre-installing dependencies, tools, or specific operating system. No more waiting for workflow to download the required packages every time. Cost efficiency. If you're running large-scale or resource-intensive builds, cloud cost can add up quickly. Self-hosted runner can save you money by utilizing your own infrastructure. Enhanced security. For projects requiring sensitive data, self-hosted runner let you keep everything within your private network, ensuring maximum control. If any of these resonate with you, it's time to deep dive into the setup process. Now let's jump into the demo. So first of all, we need to prepare our machine. It can be your Linux VM, a Windows system or Mac OS device. The first step is to update the system and install any necessary tools. So in case if we need to install Pylint, so we can go ahead and install the Pylint using the pip3. We install the pip3 first. A pip3 got installed. Let's install the Pylint again. So in the similar way, we can install any of the dependencies or required packages to run our workflow. Now to add the runner into the GitHub, we need to navigate to our GitHub repository. So we need to go into the repository settings, and inside that we have an option called actions. Then we need to go inside the runner, and inside that we have an option called new self-hosted runner. So once we click that, it will give us three runner images. One is macOS, Linux and the Windows. Right now we are using a Red Hat based machine. So for that we need to go ahead and click on the Linux, and then it will give us a script and the commands to execute on our machine to register the runner. So first of all, it will give a command to create a folder. So let me run this one. So it creates a folder called actions-runner and get inside that particular folder. Then it will give a command to download the latest runner package. So let me download that. Once it got downloaded, it gives a command to validate that hash for that particular tar file, and it's an option, so I'm not running it. So now it's time to extract the installer. So tar file got extracted. So let me get back to it and let's configure this runner. So there is another command which creates the runner and set the configuration. So let me run this. It's setting up the authentication and connects with the GitHub. It's asking to enter the group name here. So I'm not going anything. So I'm going with the default one. Now it's asking for the name of the runner. So press enter. And if I press enter, then it will give the default name, that is a GitHub-runner. Now it's asking for the additional labels. So I'm giving some kind of a label that is test-runner. Now it added the runner into it. Now it's asking to enter the name of the working folder. So I'm going with the default one, that is _work. Now all the settings got saved, and it's giving us a last step to run the run.sh script. So let me run this. So this particular process will be running at the backend. And if I go back and click on the runners again, we can see one runner is there and it's idle. Till the time this particular script is running, the runner will be live over there. But if I cancel this particular script if I come back here and refresh this page, it will show as offline. So if we want to run any job, so we need to run this particular script. Till the script is running, then only we will be able to execute the operation on our runner. There is another option in this particular tar file which we have extracted. So let me do ls, and here is one file that is svc.sh. If we run this particular file, it will create a service of this particular runner, and it will be running at the backend irrespective of the shell script. So let me run this one. So it's asking to use a sudo user, so I'm going with the sudo permission here. So it's giving us a different option. So right now, install, start, stop, and status. So right now we need to go ahead and use the install option. So I'm going with the install. So it started the service, that is the action.runner. So let me check the status of it. So it's not loaded, and there is another option in this script itself, so we can check the status using this command as well. So it's not started. Let me start it. So we can use this script to start this one. This particular service is getting failed. I know the issue why this particular script is failing, because internally this particular script is using the run svc.sh script, and the context of this SLNS context of this file is not correct. So let's set the right context of the script. So for that we have a command that is chcon -t bin -t is the context and the script path. Now it's done. Let me run the same command again, and we can see this particular script is running. Now our runner is running. So let's go back over there and do the refresh of this particular page, and we can see this particular service is run because that particular runner is running as a service at the backend. Now let's modify our code to use the self-hosted runner. So let me go ahead and modify this. First, let's check the name or the label of this. So if we go in the runners tab, and we can see these are the labels which we can use to call this runner. So I'm going with the test-runner. So let me edit this file. So instead of ubuntu-latest, we can use this label that is test-runner and commit the changes. Now let's navigate to the action tab, and we can see two workflow got triggered. First is hello world, and we can see this particular runner will be running on our GitHub runner, that is the self-hosted one. And that's it. We are able to set up our self-hosted runner. Before we wrap up, here are a few pro tips to help you manage your self-hosted runner efficiently. Always keep your runner updated. This prevents bugs and compatibility issues with new GitHub action features. Use label to organize runner for specific tasks or teams. For example, label one runner for building, another for testing. Regularly monitor system resources like CPU and memory usage to keep things running smoothly. Automate cleanup of temporary file or old build artifact to avoid storage issue. Lastly, secure your runner by limiting access and using strong authentication token. Follow these steps and you will ensure a seamless experience with self-hosted runner. And that's it. We have just set up a self-hosted runner for GitHub Actions, opening up endless possibilities for customization, cost saving, and security. In our next video, we will take this setup even further by automating linting for Ansible playbook using Ansible lint on the self-hosted runner we just configured. Make sure to hit the like button, drop a comment if you have questions, and subscribe to stay updated. Thanks for watching. I will see you in the next video. Let's keep automating.